Hi everyone, we are going to present our research, the use of conversational interfaces in long-term patient care. Authors of the research papers are Sanjani Gunatilaka, Udani Veerasinghe, Ishara Vikramasinghe, Mr. Viraj Velgam and Ruan Singha. First move to the introduction. Long-term care. Long-term care involves a variety of services that facilitates the medical and non-medical needs of an individual during long-term period of time which exceeds 3 months of period. When people cannot perform their daily tasks independently and safely on their own, they can use the services provided by the long-term care. Older adults can also be considered as the long-term patients somehow, even though long-term care is not limited to the elderly. The vast majority of long-term care recipients are older. 7 out of 10 people over 65-year-old require some sort of long-term care services in their lifetime. And there is a 50% chance of requiring long-term care for a person who reaches the age of 75 years. Taking care of a patient or an elderly parent would be difficult in this era as many people are so busy with day-to-day schedules. Patients as well as old adults who are in the same place for a long period of time may raise issues such as isolation, loneliness, and boredom. They also may be compounded by mobility issues. Conversational interface is any user interface that emulates a conversation with real humans using its own human terms in a way that humans only need to tell what image processing is used in the VIPA technology. Voice-integrated conversational interfaces are more suitable to assist long-term patients in many ways. It is easier to speak and ask something, especially for patients with vision impairments or mobility issues. They provide immediate response as well as they can ask the same thing several times if they have issues with comprehensions. There is a challenge for patients and seniors to interact with computers and to do texting like this, so it is a good fit for seniors. The study mainly focused on figuring out answers to 3 main research questions as what are the most common issues facing the elderly in assisted living, which of these issues can be addressed using an automated conversational interface, what are the most effective ways of improving the quality of life through a conversational interface. The scope of the research was based on targeting a group of patients who suffer from long-running illnesses and who could not handle their day-to-day life without immediate care of a person aged between 60 to 95 who lives in home environment. We consider voice-integrated personal assistant as conversational interface as it is more suitable for the target group. We conducted a systematic literature review on the use of conversational interfaces in long-term patient care. There we used 5 stages of conducting a review and we collected papers under 3 main areas that mentioned here. According to the systematic literature review, we identified there's a knowledge gap in the research community in the domain of investigating a way to cater these conversational interfaces to long-term patient care space. Only few closely related papers are mentioned here. This is a study carried out in 2019. It discussed the application of interactive home healthcare system with integrated voice assistant. Researchers focused on solving the obstacles patients face when using wearables health sensors in their home environment. This is another study conducted using activity recognition as a service for a smart home. In the study, they mainly focused on identifying the physical activities of patients.
When it comes to the research methodology of this research, to conduct research in a more constructive way, we use design science research methodology, which includes following steps shown in this figure. So that is awareness of the problem and literature research, a suggestion and development of initial design, and demonstration and evaluation of the solution, and communication with related community. As for the first phase, one, awareness of the problem and literature research, we conducted an interview study and explanatory study based on reviews of Amazon Echo. Mainly, an interview study was conducted to get answers for our first research question. What are the most common issues facing in elderly and in assisted living? So this interview study mainly focusing on individual long-term patients and caregivers. So it includes 2 questionnaires. The study sample was included 20 individual long-term patients and 11 caregivers. And those patients was aged 60 to 95 and they suffered from long-term illnesses. And this was conducted in both English and Sinhala languages. So these are the related interview examples we gathered through this interview study. And these gathered data was analyzed using thematic analysis, 6 phases, and resulted themes are into we conducted into 4 clusters, and these clusters are psychological, medical, social, and communicational needs. So these are the resulted needs of those long-term patients. And this gives the results for our first research question. What are the most common issues facing the elderly in assisted living? And when it comes to the explanatory study, we conducted this explanatory study based on publicly available online customer reviews of Amazon.com. So this gives the answers for our research question 2, which of these issues we gathered from research question 1 can be addressed using an automated conversational interface. So basically we use Amazon Echo because it is a 3rd generation chatbot conversational interface, and we collected those using Amazon.com. So mainly the gathered reviews was gathered using the mention of an individual with long-term illnesses, and the inclusion criteria for reviews was segregated into 3 categories, like different types of long-term patients and related people, such as older people, and disabilities and diseases related to long-term patients like mobility issues, alone, disease, health issues, kind of and living environment like home, assisted living, and hospital. So this explanatory study based on Amazon Echo reviews. In here, we conducted 621 reviews, and we used data preprocessing, like these kind of given examples was excluded from our data set. So this resulted a total number of 455 reviews in our data set. And these are some related reviews we gathered in this second explanatory study. And this data gathered was analyzed using thematic analysis. So we analyzed it using 6 phases of thematic analysis. In first phase, we familiarized with the Amazon Echo data collection. In second phase, we generated initial codes for our data set using NVivo software tool and coded. It resulted codes of 333, and these are the initial codes we generated here. And in the phase 3, we search for themes in this collected data, and phase 4, we review themes in this area. And also in phase 5, we define and name those collected themes and resulted themes. And in phase 6, we produce the report. And these are the resulted themes and sub-themes from the Amazon Echo analysis. So this gives the answers for our second question, which are the issues, which of these issues we gathered from our research question 1 can be addressed using an automated conversational interface. So these are the basic use of conversational interfaces of long-term patients. And in the second phase of our design science research, it is the suggestion of initial design and development of initial design. So we choose functionality-centered long-term patients like customized small talk, bedridden exercise coaching, and mind games. So those was developed using Google Actions Console, Dialogflow, Firebase, and Actions on Google Node.js client. And also this development of initial design, we designed it using sample of 2 patients and 3 healthy people. The chat flow was developed like that. And this chat flow was also developed using participatory design method. So this chat flow was designed using 2 phases: the engaged target sample and gathered desired chat flow. And also then we clarified design artifact using their feedback and suggestions. So this is the basic architecture for our research design. And when it comes to the demonstration and evaluation of the solution, we collected data from 11 participants considering English literacy and mobility level. So these these data was collected using quantitative and qualitative questions. And we communicated this related the communication to this benefits of this conversational interfaces. We communicated to the target community while evaluating this.
So moving to the results and the discussion of this research. Next, please. These are the 5 main factors which we considered when we evaluating our research. When we are collecting the data, we gather data from 11 participants considering their English literacy, mobility level, and after that we use the SPSS software to analyze our data. So after that, our main first factor, Google, considering the Google Home device, there we can see 2.55 percentage is 2.55 mean is there. For I can use such a device as a caregiver, because the elderly patients expect more from a caregiver than from the Google Assistant. But there's a higher averages for other factors, which shows that they are willing to use this Google Home device, which help them to support the caregiver and the elderly patients. So moving to the discussion of this, there we can say 63.6% of patients strongly agree the language understandability, and the patients are more willing to try this technology. Moving to the our factor, our mind game feature, which was developed. So considered with other factors, this one has a low average because of the understandability of the question and due to the accent issues. So moving to the discussion of this mind game feature, we consider the understandability, enjoyability, and the interest of the patients and the speaker's ability to recognize the word. So when we consider all these factors, the main factor which we gain from the elderly patient is that they need to have more familiar questions to keep them more engaged to the game. So moving to our next main feature, which is the grading exercise feature. Compared with other factors, this one got more percentage from the elderly patients. So moving to the discussion of this bedridden exercise. So there are most of the elderly patients suggest that it's better if they can play music while doing exercises. But due to some factors, speakers cannot do parallel tasks, and it's difficult to respond the speaker while music is there. So considering those factors, those are not practical. But most of the patients are willing to use this, and from the data also we can see that they expect they can get some sort of a mobility by doing these exercises. So our next feature is the talking companion feature. So in the talking companion feature, moving to the discussion of it. The elders are more willing to use this device to bring up a conversation and to use this when they feel lonely. So mainly they expect this device can be used when they feel lonely, considering the averages given by the elderly patients. So moving to our next factor, which is the overall experience that they gain from this speaker. There we can see high averages, which is 4.73, which it shows that it's very helpful for the loneliness and it's good to pass the time. But when it comes to the patient, since it's a very helpful technological device for them. So moving to the discussion of this overall experience. After that, we consider all these 5 main factors and calculated their satisfaction. So when we consider threshold satisfaction as 0.75. So in the next slide, we can see the graph which we got from the different patients. So there are only one patient is there which is less than 0.75. When it comes to total satisfaction, all the patient had a satisfaction more than 0.75. So the next slide, please. Both parallel with this quantitative analysis, we conducted a qualitative analysis also. So there we use the thematic analysis to conduct this. So the next slide. As an overall discussion, we use the design science research, and this is limited to the elderly patients. And the elderly patients expect that the smart speaker can be used to assist both the caregiver and the patient. So we'll move to the limitations then. The limitations that we faced was our review analysis is limited to the Amazon Echo, and our solution is limited to the Google Home device. And we did within the time frame we used one iteration of time period, and there are language barriers when it comes to this development. So moving to the conclusion from the knowledge gained from this research, we can get more knowledge from this research for the patient care domain, and we can show the importance of voice-integrated conversational interfaces for the patient care, and it improve and integrate the benefit to give the maximum benefit to the user. So when we move to the future works of this research, this can be developed for the Sinhala language, and this can be extended to the young patient and the disabled people who are hospitalized people. We can get the emotional context also to this research. So those are the future works that we can expect from our research. So these are the requirements, and thank you very much. Thanks.
Okay, so nice presentation and interesting work as well. So can all the presenters switch on your camera, please? Okay, thank you. So now the forum is open for Q&A. So can we have any questions from the audience?
Yes, may I ask a question? I'm Lasit Gunawardene.
Yeah, sure. Go ahead.
Yeah, I think in the first part of the paper for the thematic analysis, you have used this Amazon Echo for the review part, and then when it goes to the implementation, you moved on to Google Home. Is there any particular reason why you decided to switch as such? Any technical reason or?
Actually, mainly we focused on the Google device, but when it came, we did the review analysis because from the Amazon page we could collect the reviews from different types of patients. But with the Google, we cannot collect those reviews. There's any separate page for that. So we just use this Amazon Echo just to get that reviews from the elderly patients.
All right. Okay.
I have a question that you have a satisfaction level which is between 0 and 1 in that table. So is that the earlier scale that you had from 0 to 5 is scale to 0 to 1, or how did you get that number between 0 and 1 satisfaction for different categories for each patient? You had a questionnaire, right? Questionnaire data.
Yes. We collected data as a qualitative, both qualitative and quantitative data. So after getting this quantitative data, we use the SPSS software and get those values up to from 0 to 1. So when it comes to there's an equation we used to calculate the satisfaction.
They are based on answers given, right? So
yeah, based on the answers. So if they satisfy, they give a 5. If they are not satisfied, they give 1. So based on those satisfaction, their ratings, we got that satisfaction levels.
Now, one other question I have is like, now if you take a driverless car, that cannot be that software has to be certified because there is a safety issue. Now in your work, I have seen that there is something called bedridden exercises for this elderly. So if they are ill and so on, somebody without human intervention trying to do exercises with bedridden patients. So have you thought about that? I personally, I think this kind of things have to be done with human intervention. Then only it becomes a care. So this is basically kind of a robots doing elderly and elderly care. I'm not blaming you, but I mean, this theme of this research is not my interest. So that's why I said this.
We are like, we just want to get an overall idea. So we just developed based on the, we got some information from the few doctors also and developed these exercises. But in this, when it comes to a special patient, so if there are different types of diseases, or if there are mobility issues, we can customize those exercises. So based on the diseases that the patient has, so we can customize those exercises. So from the Google device, we can develop those different exercises based on the necessity of that patient. So we just did this to get overall idea. So whether we can do it in practical level. So if we take a special type of a patient, we have to go, we have to customize actually those features.
But also in legal terms, whether there is this will be allowed is another question, whether this will be allowed. So you have to probably get a certification for your software before using this.
Yeah, that's true.
Hello.
Hello.
Yeah, my name is Chamari. I really like your presentation. Thank you very much for presenting. So my question is that how long have you done this user study?
We have done this within a 1 year period of time. So we start it's not dragged up to 1 year, about 10 months.
So about 10 months, the elderly people are interacting with your system.
So it was the final stage. So within this 10 months, first we did that review analysis with using that Amazon Echo page, and after that we identified the necessities. Then we did some development. So at the later stage, for about 1 to 2 months, we interact with the patients and let them to use this Google Smart Speaker and get their feedback.
So it is just 1 to 2 months.
Yeah.
That they get to interact with the. Yeah, the other thing is that I saw at first that you talk about that you actually get the data, some interviews out of the actual caregivers, I mean the human caregivers. I don't see that in the end. Do you have those information as well?
We got the information from these caregivers. When you are starting the research, so what sort of a needs that the patients have. So to get the domain idea, we interact with these caregivers. And based on those reviews and feedbacks, we develop our solution. So we mainly did a qualitative analysis for that with the caregivers. But when after the development, we mainly did a quantitative and both quantitative and qualitative.
So let me get this clear. So you only get the caregivers data, you only did the caregivers interviews to facilitate your system, not about the system, right? Because you didn't get the, no. Okay, right. That's what I wanted to clarify. Okay, thank you very much.
Thanks.
Do we have any more questions?
Hi, Lasamji Chamintaranasinghe.
Yes.
Right. I think it's first thing very interesting and for young people to think about elderly. So it's a great, I think, motivation for all the girls and boys to do this. My only broad question, it's not a question, it's more of a kind of a remark. I think the earlier member in the panel asked the same question. It's whether you can, because I think we are trying to use technology to solve the human interaction issues, and in terms of the scope, the loneliness, and in terms of people who are away, who's not getting having human contact, we are trying to augment it in a way which is good if you can do it. But I think the broader question is, to what extent have you thought of or even analyzed replacing the actual human interaction? Or is it kind of a dual mode that you can use it together with humans initially, or human interactions and this as a kind of augmentation? What's your view on that?
Yeah, so mainly like based on the results also, it shows the elderly patients, for now the elderly patients, they are not willing to use only the smart speaker. They are like they are willing to use the speaker as a supporter. They are not willing to give up the human care and just go with the speaker. So for now, we just as the first step, I think it's just a support for both the caregiver and the patient. So with this smart speaker, mainly we consider about building a conversation. So if we can customize based on the patient's interest. So mainly these elderly patients, they are so willing to talk with the people. So we think if we can customize based on their interest, it's a good phase to think about. And for the exercise also, we are mainly thinking about customizing based on the patient's requirement. Yeah, so it's not just only with the speaker. We think both the speaker and the caregiver.
Okay, right. Thank you.
Thanks.
Okay, I guess there's no more questions. So thank you once again for the three speakers and for the questions as well. Thank you.
Thanks.
So now we can move forward with the next session. So now we have 7 round. Yes, sorry.
So there's a special announcement for the best paper selection committee members. So it will be highly appreciated if you can join the 3A bioinformatics session. So if you can join the 3A bioinformatics session. Over to you, madam.
Okay, thank you. So now we have 7 poster presentations. So for these poster presentations, 5 minutes will be given for the presentation and 2 minutes for Q&A. So the first poster presentation, which is paper ID 7, is on mobile learning, modeling the influencing factors on mobile devices. So the presenter is Dolavatta, and he obtained his BSc in Physical Science degree from University of Kelaniya in 2001 and MSc in Computer Science from University of Colombo School of Computing in the year 2007. So at present, he is reading for PhD in Computer Science degree at the University of Sri Jayawardenepura. So Can we now play the video, please?
Good morning. Let me allow you to present our research titled Mobile Learning Modeling the Influencing Factors on Mobile Devices. I am the research student and my name is DTM Dolawat. My supervisors are Dr. Salinda Premadasa and Professor Prasad Jaivira. First of all, I would like to do a brief introduction to this research. Today, there is a big improvement in learning via mobile devices. Because of the mobile devices' popularity, continuous development in mobile devices and technologies, preventing classroom-based education due to busy life cycles, finally, present health requirements make the importance of social distancing and demand for mobile-based education. In this study, we want to discover influencing factors for learners and teachers to use mobile devices to adapt in the applicable and sustainable mobile learning environment. Next, let me allow you to present the objectives of this study. Objectives are investigating influencing factors of the university community to use mobile devices in education and investigating suitable features of mobile devices in education and study the influence of mobile device features for higher education such as screen size, screen zooming, touchscreen keyboard, video playback control, support software and language predictive tools. Figure 1 shows the proposed impact model for learners and teachers to use mobile devices in applicable and sustainable mobile learning system in higher education. The main hypothesis is that selected mobile device features will have a significant influence on learners and teachers to use mobile devices for adopting applicable and sustainable mobile learning system. Next, I would like to present the system functions and architecture of the system used in this research. Moodle mobile app was customized and used to implement the proposed impact model. For that, a couple of new features were developed as a plugin and integrated into the Moodle mobile application by the first author. Figure 2 shows a few selected interfaces of the mobile application. Interface A denotes playback control setting, B denotes button-based screen zooming, C denotes language predictive tools. Next, I would like to present the methodology. A questionnaire was developed based on the proposed impact model for both learners and teachers in the pre and post-test surveys. Evaluation was done based on the 5-point Likert scale, values from -10 to +10 for strongly disagree to strongly agree. 60 university students and 60 university teachers consist of the sample. Data analysis was done using the paired sample t-test and Pearson correlation coefficient test. Next, I would like to present the results. Table 1 denotes that each mean value is greater than 5, which means each observed variable has a significant influence on the users to use the proposed mobile learning system. Also, according to the results of the paired sample t-test, p-values are equal to 0.000, which is less than 0.005, and it implies that the original hypothesis was accepted. The last table shows the results of the Pearson correlation coefficient test. It denotes that each p-value is less than 0.05, which means the original hypothesis is accepted. The correlation of each observed variable is greater than 0.5 and close to 1. This implies that each observed variable is strongly connected with the latent variable called mobile device. The last figure shows the propose impact model with correlation. Finally, I would like to present the conclusion and implications. The results imply that screen zooming is the most significant influencing factor for learners and teachers to use mobile devices for adapting mobile learning. So, mobile learning content developers and designers should realize that their priority must give to the mobile device features considered here, particularly screen zooming when designing mobile learning applications. So that's it, my presentation, and thank you for watching and hearing, and please ask any questions. Thank you.
Yes, Mr. Dolavatta, can you please switch on your video? So we can accommodate 1 or 2 questions. Do we have any questions? Mr. Dolavatta, you are there, right?
Yeah, yes.
Okay. So the sample size is somewhere around, you have tested this with 60 students and 60 teachers, right?
Yeah, 120.
Yeah. So how did you kind of select the sample?
Actually, I selected university students, 60 university students and 60 university teachers. There is no regular method or proper method. I asked whether they can join to my research. Then actually, when joining teachers for this research, I asked them to they are join their teachers, students also. So they joining, they are joining their students as well. So likewise, I gathered the sample.
Okay, thank you. Any questions from the audience? Looks like we don't have any questions. So thank you, Dolavatta, for the presentation.
Thank you, ma'am.
Yeah. So next poster presentation is paper ID 57. And the paper title, A Mobile-Based Alphabet Learning Game to Intervene Dyslexia Among Children. So this will be presented by Roshan Abevida. So he received the BSc degree in Information Systems from University of Colombo School of Computing in 2020, and his current research interests include ICT for development, e-learning, and natural language processing. So can you please start the presentation?
Hello, I'm Roshan. Today I'm going to present an initiative taken by us to intervene dyslexia among school children in Sri Lanka using game-based mobile learning. Before move on, I would like to speak about dyslexia. Dyslexia is a language learning disorder. In simpler terms, a child having dyslexia can't read written content. The main reason for that is inability of them to identify speech, sounds, and how they related to letters and words. Most importantly, this disease doesn't have any effect on IQ level of a child, but this disease condition is one factor which causes school dropouts and school bullying. When talking about treatments for dyslexia, there are no specific way to do treatment, but it can be managed with special instructions and support. In Sri Lanka, these special treatment units are only limited for few hospitals, and additionally, most of the parents and teachers outside the main cities of Sri Lanka are not aware of these disease conditions. So for Sri Lanka, a good initiative is required to make awareness among community, as well as to make available special support to every dyslexic children, irrespective of his or her location. Here, we have designed and developed a mobile game instead of traditional treatment sessions or therapy sessions, which are conducted using pen and paper. So we designed this game based on the three stages of the reading acquisition: logographic stage, alphabetic stage, and orthographic stage. Logographic stage is the stage where a child tries to identify a written content based on a visual memories, such as images. If child succeeds in the logographic stage, then he or she get ability to map written content into speech sounds, which is known as alphabetic stage. A child who has gone through both of above stages get ability to decode any written words based on the knowledge he is gained through the above two stages. So we design our game activities as a way which gradually move from logographic stage to alphabetic stage. There are two types of difficulties faced by the dyslexic children. There are visual processing difficulties and auditory processing difficulties. Visual processing difficulties is they find it difficult to identify letters with the same shape, and auditory processing difficulties is they find it difficult to identify letters with same sound. So we have given a special emphasis for these letters in our advanced levels in the game. This slide shows some screenshots of our game. For the experiment, we were only able to find 6 children who have been diagnosed with dyslexia, and they were at age range 6 to 8. And what we did was we divide them into 2 groups as a control group and treatment group, and then we exposed this treatment group into 21 gaming sessions in addition to normal therapy sessions and treatment they are getting from hospitals. So after the 21 gaming sessions, what we observed was every child at the treatment group have show some sort of improvement over the 21 days with compared to the control group. In addition to that, we have conducted a survey by giving a questionnaire to pediatricians, speech and language therapists, and in this slide we have shown the 2 statements which got the maximum mean score. The first statement is, this game-based approach helps the students to improve interest in learning, and I recommend this game for dyslexic students who are in letter identification level as a supporting tool. Also, we get feedback from the parents of the participants, and what they mentioned is the attention of their children retain long when using mobile application when compared to normal therapy sessions. This is the end of our post presentation, and thank you very much.
Thank you. So are the presenters available?
Yes, madam.
Okay, so can you please switch on your videos? Okay, right, thank you. So now the forum is open for Q&A. Any questions from the author? Any questions from the audience? So what I have observed is that you have selected only 6 children, right?
Yes, ma'am.
For the sample. So, and for the treatment and the control group, how did you kind of divide the sample?
Actually, we did a pre-test. So we give them a pre-test, and based on the marks obtained from the pre-test, we divide those students into 2 groups in a manner that both groups have same level of marks.
Okay, thank you. Any future plans with regard to
Yes,
the
madam.
application?
Yes, we need to polish that game and we need to publish that in the Google Play Store. So, so that dyslexic children can use it as a supportive tool in the near future.
Okay. Yeah. Thank you, Roshan. And
Thank you,
wish you all
ma'am.
the best as well. Okay. So the third poster presentation is paper ID 63 and the paper title is Automated Software Testing on Mobile Applications, a review with special focus on importance, tools and challenges in Android platform. So today this will be presented by Fatima Naja. So she's an academic and a researcher from Southeastern University of Sri Lanka and is currently following her postgraduate degree in software engineering at University of Malaya, Malaysia. So she received her Bachelor of Science in Computer and Information Systems degree from Sabaragamu University in 2016. Her research interests are software engineering, business intelligence, big data, and IoT. So can you please now play the video?
Sorry to interrupt you, ma'am. I think the
Yes.
relevant presenter is not available due to some
All right,
unavoidable
okay.
circumstances. I just want to make sure whether, because the naming seems to be different when it comes to the participant names. Can you make sure whether she is available in the list? I mean, participant?
Yes, yes.
Naja?
I'm available here. Yes.
You are available, right?
Yes, I'm available here.
Okay,
Okay,
so
then
now.
it's fine. Okay, I'll play the video.
Yes, sure, thank you. I think we can't hear.
Hi everyone, a warm greeting to everyone and especially to the conference chair on the panel. This is Najam Mustafa, one of the authors of the presented paper, and I'm here to present our research work on behalf of the authors of the paper titled Automated Software Testing in Mobile Applications, reviewed with special focus on Android platform. As I commence with my first presentation of our research work, let me give you a brief introduction to the objective and the motive behind this review research. Despite the works done by researchers and practitioners about the numerous techniques for software quality assurance, it is widely accepted that software testing is the most practiced approach for evaluating and assessing the quality of a software product. The main goal of this paper is to provide the insights from successful research works carried out on automated software testing and testing techniques for mobile application, which appears to be the most significant points relevant to the topic. And the main research questions as listed here are coming under the four main topics like what are the importance of automation and why automation is important and how automation is done and the techniques which are used in automating software testings and the challenges in automation testing. And the second part is the methodology, and this study adopts a systematic literature review process proposed by researchers on performing systematic literature review in software engineering fields. The main research questions in this review and the discussion part mainly due to the focus on the research questions. The search for a study was conducted in the electronic search spaces like IEEE Explorer, Science Direct, and Digital Library. And the ACM Digital Library, and the electronic databases were explored with a chart of research questions based on the keyword search as listed here, and the papers were removed for redundancies, and irrelevant studies were removed according to the inclusion and exclusion criteria as listed here. And there's third main part, and moving on to the results and discussion part. The results and discussion of this research work or the review work is discussed under the four main research questions. The first one is, what is automation testing, which means what does automation testing refers to? And according to this, the definition given here is from the paper of authors Agrausi and Mantilla in their work published in 2016. They say automation testing is the use of special software separate from the software being tested to control the execution of tests and the comparison of actual outcomes with predicted outcomes. Although various researchers define the term automation testing in their own style of wording, none of them have wished to portray the same concept, and according to literature, it stated that testing takes up to 50% of the total cost of any software development. It is sometimes even more than that, according to some literature. As this is a fact regarding testing costs, it is essential to manage it, and it is one of the goals of automation testing. And as listed here, the other goals of automation testing is minimizing human errors and making regression testing easier, which means that it is mandatory to thoroughly study which approach is to be used for the purpose of testing in order to avoid future errors and failures in testing. And the second question, research question, which is discussed here, is the importance of automation testing on mobile applications. And as you all know, mobile applications or mobile phones are being used as a common platform to manage tasks for everyday life and activities. Since its involvement has become a norm in our lives, for every mere and essential task, getting breakdown or unexpected behavior of any sophisticated mobile application can result in a great disaster for industries and enterprises. Hence, therefore, the user's unpleasant experience of crashing or bugs while exploring any mobile application can be a consequence of the stakeholders stop using it. Therefore, to avoid the consequences, after all the time, energy, and money invested on mobile application, various software testing on mobile application is certainly necessary. Therefore, meeting graphical interface schedules and functional requirements and flow of the app can be achieved and may attract to users. Therefore, ensuring high quality is essential than anything else, which is one of the major importance of adopting automation testing in testing mobile applications. And the third research question is, what are the testing techniques and tools used in automation testing of mobile applications, and especially the Android platform. And to summarize the facts, it is a tabulated fact is given here, and the techniques, advantages and disadvantages of each relevant technique, and the tools which adopts these techniques have been listed here. And as major technique types, there are three, and the first one is random technique, and the second one is model-based technique, and the third one is a record and a replay technique. And for each and every technique, there are advantages and disadvantages, and the tools column shows us there are existing tools which have been adopted using these techniques, which are used in the automation testing of mobile applications and especially for the Android platform. And the final research question and the final and the fourth one is the challenges in automated testing of mobile application. As you know, several studies that have been conducted by many researchers come to some common major challenges they have found, but some significant founds which were noted, like mobile applications are very different from traditional ones, and thus different and specialized techniques are involved in testing, and there are many challenges, most still with no optimum solution. And the four major challenges which are listed here is like device fragmentation, device limitation, input interfaces, and rapid application development. Like although a number of challenges may increase, it could be mitigated with proper use of tools and techniques. And finally, the conclusion part. From the conclusion part, we have put forward 3 main points. Like literature reveals that all the software testing techniques are involved in ensuring a quality product. But before implementing any such technique, we have to evaluate the software product. And the particular approach must be well studied because well studying of the approach before implementing would be the ideal approach for implementing any testing process. And as a second one, after thorough review of the literature, it deems best to start automation testing using existing tools, which means that, as I already discussed under the third research question, so the existing tools which comes under many techniques used, it is always good to start with the available toolkits which have been already developed by standard Android developers. And the third one is like no single strategy alone seems to be effective to cover all behaviors. The combination is more effective, which means like when we use software testing, we have to be very sure that which combination of techniques would be most appropriate for our contest. And the final one is in terms of challenges, though all the challenges cannot be exempted, still proper selection of tools shall aid in mitigating certain challenges. And that's it about the conclusion. And the final one is some bibliography of some selected references which have been used in this research work is listed here. And thank you very much for everyone for listening to my presentation. And I take this time to acknowledge the reviewers who gave some good reviews regarding the manuscript we submitted earlier and to mold our manuscript to a better one. Thank you. And apart from that, I would like to thank the panel again and the conference chair for giving me this opportunity to present our research work on behalf of the authors of this research work. Thank you.
Thank you, Naja. Naja, can you please switch on your video?
Yes.
So now the forum is open for Q&A. Any questions from the audience? Yes. Since the presentation took a little bit longer than the expected allocated time. So then thank you, Naja, for the presentation, and I will move forward with the next presentation. Now the paper ID is 121 and it's on assistive learning platform for children with Down syndrome. Today this will be presented by Sahan Vellava, who is an undergraduate at Sri Lanka Institute of Information Technology. He is currently following a BSc Honours in Information Technology, specializing in software engineering. And his research interests include assistive technology, computer vision, and deep learning. Over to you, Sahan. Or shall we play the video, please?
Yes, madam. Please, yeah. I'm Sahan Vellava, and I'm here today to present on the assistive learning platform for children with Down syndrome. This is the poster summarizes the overall approach of the system. And let us continue with the slides. Down syndrome is a genetic disorder. 1 in 1,000 are born with Down syndrome. And when concerned about Sri Lanka, there is no any assistive learning platform to improve the learning of these children with Down syndrome. And these children are often neglected from the society. The research team identified the problem as how to improve the learning skills of these children with Down syndrome from ages 5 to 13 years of mental age. In considering the literature, it can identify that there are some applications that have considered how the learning skills. However, none of the systems have the native language, which is Sinhala, and most important, they are not designed specifically for children with Down syndrome. Another thing is that this existing system do not detect the presence of the child and as well as the emotions of the child. But the main purpose of study is that to develop an assistive learning platform to improve the learning of these children with Down syndrome. The system diagram showcases the architecture of the components within the system. With the background studies that the research team conducted, the team identified the primary areas to provide assistive learning. They include language skills, mathematical skills, social skills, and health habits. Then after, the team identified the requirements of the children with Down syndrome and collected data from 3 special education centers in Sri Lanka. Accordingly, the interactive learning modules were designed with the medical supervision. Then these children are evaluated according to the cognitive scale for children with Down syndrome. This slide showcases some of the screenshots of the interactive learning activities that were created to improve the learning skills of these children with Down syndrome. In order to improve the application interactivity and to understand better, the application detects the presence of the child as well as the emotion of the child. When a quiz activity is started, if the child is not present, the animated character called Alex calls the child with a voice. And also, the application detects the emotions of the child from the camera of the laptop and with the help of deep convolutional neural networks. On the emotion, grades, and the favorite contents of the child, the application records activities for the child if a negative emotion is triggered. This is done by monitoring the variation of the emotions of the child over time. Then there is another module to improve the motor skills of these children with Down syndrome. With the customized keyboard and with the special typing activities, it helps to improve the motor skills of these children with Down syndrome. In here, the dashboard showcases all the statistical visualizations of the child. Accordingly, the doctor or a teacher can easily identify the improvement of the with the time. And also, they can identify the things like what are the areas that students like most, the overall performance of the child, and what are the quiz types attempted by these students, and so on. This demonstrates how the child with Down syndrome is a platform by herself. On the left, the scores that were obtained by those 50 students before using the platform and after using the platform. These 50 students, 31 students showed an improvement after working with the platform. And in the platform, there are 2 models to detect the emotions to give recommended. Accordingly, detection model achieved 83% accuracy and the recommendation achieved 89% accuracy. To conclude, the platform is developed to assist children with Down syndrome to improve their learning skills and to evaluate children with Down syndrome. It is showcase the plus of the platform. And in the future, plans to improve the platform to sub-centers around Sri Lanka to improve the accessibility of the platform. And,
Thank you, Sahan. Sahan, you are available?
yes, madam.
Right. So yeah, thank you. So any questions from the audience?
Great presentation, well, Lala. I would like to know how did you do that emotion analysis part? I'm interested in that.
Basically, we identify the emotions through the web camera of a laptop. That is through the facial features. That is done with actually with the deep convolutional neural networks. Accordingly, we identify the emotions, the happy, neutral, and sad. And is there any specific things that do I need to explain? Yeah.
No, I just wanted to know whether you had used any third-party APIs or.
No.
Thank Okay, so that means you trained a neural network.
Yeah.
Okay, so you categorize the features into happy, neutral, and to negative.
Yeah.
Based on some features.
Yeah, basically, yeah, that part is done by the that neural network. Before that part, there's another one to extract the facial features. For that one, actually, I use the Face API to extract the faces out of the web camera. That is actually from the web camera, we are getting a video feed, right? From there, I'm taking a frame for every 3 seconds. I can adjust that one. Accordingly, I send that frame for my trained deep neural network model. Then I get the classification.
Okay, so that means you used Microsoft Face API to recognize the emotions. Is that what you did?
No. Only to the extract the faces out of, yeah.
Okay.
For the extraction part. Yeah.
Okay, thank you.
Okay.
So I guess you are still working on the research, or what is the status?
Yeah, actually, we are working with actually 3 special education centers, and we tested our application with those children, and we have completed most of, it's like around 98% of the project, and we hope to expand our system with the by introducing it to for several other special education centers, and then after we are planning to introduce that for the e-learner centers, which will increase the accessibility for this platform actually.
Okay, thank you, Sahan. Thank you for the presentation. And now I'll move forward with the next presentation. That is the 5th poster presentation, paper ID 128. And the paper title is ETAM, a smart tool to predict safe consumption of groundwater. So this will be presented by S.B. Gunaratna. Gunaratna is an undergraduate student in software engineering department at Sri Lankan Institute of Information Technology. Currently, she works as an associate software engineer in Mobisec company specializing in mobile application development. So now can we play the video, please?
Good morning, everyone. I'm Sanamika Bandara, undergraduate from SLIIT, specializing in software engineering. It gives me a great pleasure to be in front of you all here on ICTer 2020 conference to present our research paper on the topic ETAM, Smart Tool to Predict the Safe Consumption of Groundwater. This is the poster representation of the discussing paper. Let me walk you through a quick introduction to the research problem. 59% of people in Sri Lanka rely themselves in groundwater, especially for drinking purpose. But do they really know that they are consuming safe water from the groundwater sources? Or can people be safer from waterborne diseases by consuming groundwater directly from the sources? With the availability of novel technological resources, our objective was to design a smart tool which could be used to identify the quality of groundwater to help people consume safe water for the sake of their own health and well-being. The system can be discussed with the help of 3 sub-objectives which are implemented as 3 sub-modules. The researchers introduced a water quality index, which is a single numeric index that could be used to identify the quality of water sample, where this index is widely used in many developed countries in water quality measurement analysis. WQI generally uses number of water quality parameters such as turbidity, conductivity, temperature in the calculation process of the final index. With the use of machine learning techniques, we have used pH, temperature, turbidity, conductivity, and total dissolved solids in the prediction of WQI using regression machine learning algorithms. In addition to the water quality identification, there are 2 other important features that have implemented in the system. CKDU, which is known as chronic kidney disease of unknown etiology is a major problem that occurred in Sri Lanka due to the water quality in mainly North Central province. The system predicts exposure to CKDU with the given sample of water. The risk is predicted based on location of the sample of water and the values of water quality parameters using classification machine learning algorithms. There are 4 monsoon seasons in Sri Lanka. With climate changes that comes with this seasonal change, the values of the water quality parameters also change. With the functionality of predicting the future values of the water quality parameters based on their location and the past values using regression machine learning algorithms, system delivers uses the ability to identify the variations of the water quality. Having discussed the main 3 sub-objectives, let me go through the results of the implemented system. Each sub-module of the system gained high accuracies for their predictions. Prediction of WQI with 97-point accuracy, predicting CKDU with 76.32% of accuracy, and forecasting parameters with accuracy of 83.24%. We did manage to create our system with an overall accuracy of 73%. With internet penetration increment rate at an all-time high with 53% of global population, and with the consumer approach survey, more and more population adapting to the usage of smartphones or feature phones. It was decided that its best approach of adoption to develop a mobile application as a mode of delivery for the intelligent system. The mobile application in its initial scope will have the ability to predict the WQI and display necessary suggestions based on quality of the water. The location selected based on the water source will be able to forecast water quality parameters and also detect the possibility of any CKDU outbreak. Lastly, I'd like to give my sincere gratitude to the National Water Supply and Drainage Board, National Building Research Organization of Sri Lanka, National Hospital of Anuradhapura for providing the required data set and guidance for the research project. We believe the system we created was an effective initiative which could be used by any users in identifying the quality of groundwater. Thank you.
Yes, thank you for the presentation. So may I know whether the present is available?
Yes.
Yes. Now the forum is open for Q&A. Any questions from the audience? Yeah, I'm a little bit curious about just to know as to what is the current status of the research.
Actually, ma'am, at least 95% of the research part is done. Like we have to test with other, like we only tested it 30 into 40 water samples with the developed system. So we need to collect another water samples and test the system for increasing the accuracy. And also we have to publish the Android application and host our servers in the AWS servers. Other than that, most of the research part is done.
Okay, right. Thank you. Thank you for the presentation. And now let's move to the next poster presentation, paper ID 95. And the paper title is Deep Learning Based Sinhala Optical Character Recognition. The presenter is Isuri Anuradha. Isuri Anuradha is currently working as a research assistant at the Language Technology Research Laboratory at the University of Colombo School of Computing. She received her bachelor's degree from the University of Westminster, UK, and her current research interests include machine learning, deep learning, natural language processing, and computational linguistics for low resource languages. Over to you, Isuri, or are we going to play the video?
Yeah, I will do my share video.
Yes.
So, hi.
This abstract representation is about deep learning-based Sinhala optical character recognition. And myself, I'm Surya Anuradha, and other co-authors of this paper is Shamil Liyanage, Harsh Vijayawardena, and Dr. Vanveer Singha. And this paper is presented on behalf of Language, Technology and Research Laboratory, School of Computing, University of Colombo. So let me give a brief introduction to this project first. Optical character recognition is a highly discussing topic when recognizing printed text or characters into machine operatable text or characters. So when considering globe, there are a different number of languages where humans use to communicate with each other. So most of languages like English, German, French, which are based on Latin-based languages, are considered to be high resource, while others remain or considered to be as low resource. Sinhala also considered as a low resource language, which is complex and based on Abugida script. Integrating OCR or integrating optical character recognition technology for this kind of low resource languages need added commitment on both linguistic and computer science domain areas. So when considering the literature, what we found the complexities which exist in the current environment. So first thing is the complexities with the writing system. Since Sinhala, as I mentioned earlier, it is based on the Abugida scripts, lot of rules and combinations and formulations are inside this writing system. And most of studies were unable to identify these complex characteristics which are exist in writing system of Sinhala. And next, the lack of training data. Actually, what we mean training data in here is the prepared data which is suitable for computer which is using for optical character recognition. 2 decades back, it was so hard to collect this kind of training data and it's a lot of time consuming to prepare those training data. So another main complexity which we saw is the font types. Actually, when considering Sinhala, it has a comparatively low font types, and from that also, in practical environment, people are using small or 4 or 3 number of commercially or commonly used font types. So most of studies have only focused 1 or 2 font types which are exist, but they have neglected other font types which are used in practical environment also. So this is what we propose in abstract way. User can input image and from the OCR engine, user will be output and this output will be pre-processed and then the result will be sent to the user. So I would like to give an overview about this proposed method. So in here, I would like to give an introduction what is Tesseract. Actually Tesseract is a OCR engine which is freely available and open source developed by Google, and in here all the pre-processing parts of the images like binarization, noise removal and color changes are doing, and then after all we can plug deep learning classification algorithms like long short-term memory for here. In here we are substituting our UCC 10 million word corpus and 400k distinct word list because in deep learning mechanisms more data means absolutely good accuracy. And also, as I discussed in earlier, most of studies are only focused on one font type, but in here we are building for models which are combining 2 or more font types like Scholarpother, Multiweb, and LGLAC. So as the results and evaluation of this abstract paper, we are just mainly divided into 3 categories like Sinhala old newspapers, Sinhala old books, and contemporary Sinhala books. And these are extracted within different years of Sri Lanka. And from that, we can see Scholarpother has able to give good accuracies in 2 categories, and other combined model with Notosans, LKLAG, and Multi were able to give good accuracy is in identifying Sinhala old books such as Saddharma Alankara, Saddharma Rattanavaliya. So apart from this, we have done another classification with how image quality and how text genres will be subjected to these accuracies also. So So as a future planning, we have planned to combine post-processing mechanisms with these LSTM, with these proposed optical character recognition method, and then after all we are planned to combine connection temporary classification with deep learning algorithms such as LSTM models to train the label unsegment sequence of Sinhala language. So that's simply what our abstract paper represents, and now it's time for questions, and thank you.
Thank you, Isuri, for the presentation. So, Isuri, can you please switch on your video? Yes, now it's time for Q&A. Any questions from the audience? Any questions? Okay, so Isuri, I have one question. So you have mentioned that you will be testing this for, you will be considering different font types. So any specific, so how did you kind of select those font types? Or any specific, or are you going to test it for collective kind of font types?
Actually, when selecting font types, we were used to find some commonly used font type in Sri Lanka today. In that case, we have found the Unicode font types. We have found Washita Complex, and then after FN and Maliti and Skolapota. These are the font types which are used in Sri Lanka today. That's why we selected those font types and built our model by combining these font types.
Okay, Siri, thank you for the presentation. And now let's move to the next presentation. So Ms. Tilini Lakshika will do the last poster presentation on abstractive web news summarization using knowledge graphs. The paper ID of this paper is 140. So Tilini Lakshika is an assistant lecturer at the University of Colombo School of Computing. She received her BSc degree in Computer Science and Technology at the Uva Wellassa University in 2017. She is currently reading for the MPhil at the University of Colombo School of Computing, and her research interests focus especially on NLP, machine learning, and data mining techniques for abstractive text summary generation. Over to you, Tilini. So shall we play the video, please?
This is the research presentation for Abstractive Web News Summarization using Knowledge Graphs. I am Tilini Lakshika. As the overview, first we are looking into introduction, then literature review, methodology, evaluation, and finally the research contribution. In this era, we are moving from newspapers to news websites. As a result, news websites are becoming increasingly popular in the world. These news websites provide a large quantity of information for every news topic than actually what is needed. You also might have various experiences as an e-newspaper reader. We are really overloaded with lengthy text contents where smaller versions would do. This happens because most of the such electronic news collections lack summaries. But for us, extracting knowledge manually from a collection of newspapers may cause confusions. Sometimes we may miss the track and it's really time consuming. Due to this, the selection of best collection of information for a particular news topic in a minimum consumable time is still a big challenge. What if we can condense and extract only the essence as a summary, which allows readers to make effective decisions in less time? Already there is a solution which is known as automatic text summarization that proved to be very useful over manually summarizing the large content of data. But you know that human languages are very complex and abstract, so generating automatic summaries that are analogous to human created summaries is still a big challenging research problem. So this is the literature review that we conducted so far. I will brief them. Extractive summarization extract only the important sentences from the original text document based on the several statistical features such as location of the sentence, keywords, word frequency, and then produce a summary without changing the original text. Abstractive summarization understands the original text document using linguistic methods such as morphology, syntax, semantic, pragmatics, and then they generate new sentences by improving the focus of the summary. These abstractive techniques can be further classified as structured and semantic-based approaches, where semantic-based approaches provide more coherent, information-rich, and well-structured abstractive summary than structured-based approaches. According to the literature, semantic graph-based approaches are successful over other methods for summarization. On the other hand, machine learning approaches have greatly improved text summarization methods, but the issue is they cannot be combined with the background information to obtain higher level of abstraction. A research by Gupta et al. Mentioned that the semantic-based methods are not able to achieve similar performance to the machine learning approaches. Recently, Wu et al. And Kalpa et al. Highlighted that in order to understand the text well enough, we need some background knowledge. So they used a state-of-art technique, knowledge graph, to generate automatic text summaries. As you can see in this image, knowledge graph contains nodes indicated by circles and edges indicated by lines. Knowledge graph capture domain specific and add rich and explicit semantic to incorporate additional knowledge. Knowledge graphs are huge. They encapsulate a large amount of knowledge for human and machine consumption. Graph-based approaches use a ranking function to determine the relevance of these edges and nodes for inclusion into the summary. Traditional ranking functions gives more importance to words that are more frequent in the document. So this kind of ranking algorithm can be less effective. Increasing the set of attributes to include semantic properties and topological graph properties in the ranking algorithm will be a good solution for this. Normally, knowledge graph led to information overload, so we move toward techniques in the data mining to discover valuable and interesting information in the text and summarizing it into useful information. Among these data mining techniques, association rule mining can be used to discover correlations between multiple topics in the text document. As you can show in the figure 2, after the basic text pre-processing steps, association rule mining is applied to the text and derive all the significant association rules from the phase 2. In the phase 3, knowledge graph is formed with the ontologies and lexical databases such as WordNet, and a novel ranking algorithm which includes linguistic and semantic features along with the knowledge mined from the association rules will be used to select the top K entities from the knowledge graph. In the phase 4, abstractive summaries are generated using the simple NLG language generator. Updated summaries are generated for an existing abstractive summary. Also, generated correlations between multidimensional features in the news documents are used to generate multidimensional abstractive summaries. The collection of news documents released by Document Understanding Conference will be used as the experimental data set. In the phase 5, human evaluation using the domain experts will be carried along with the intrinsic evaluation techniques such as recall, precision, and raw evaluation. As the research contribution, we are constructing a framework based on knowledge graph approach to generate more readable abstractive summaries for multiple news documents along with the novel ranking algorithm with a better composition of linguistic, semantic graph properties along with the knowledge derived from the association rule mining. Generating abstractive summaries for multiple topics in the news documents and generating abstractive updated summaries for an existing abstractive summary are other research contributions. So these are the references, and thank you.
Thank you, Tirini, for the presentation. Tirini, can you please switch on your video?
Yes, madam.
Yes, now the forum is open for Q&A. Any questions from the audience? It's like we don't have any questions. Anyway, Tirini, just can you please briefly explain as to how you are planning to do the evaluation?
Madam, for the evaluation, I am using the
dataset downloaded by the Document Understanding Conference. It contains a set of news documents collected by some foreign newspapers, such as Financial Times, Wall Street Journal, and so on. It contains around 300 newspapers for 30 different topics. And also for these 30 different topics, it contains around 10 different articles with the abstractive summary generated by the domain experts. So we are using those abstractive summaries, which includes in the Document Understanding Conference, as our evaluation dataset for the evaluation.
Okay, thank you, Tilini. So then, if we don't have any more questions to ask from Tilini, we can conclude the presentation as well. Thank you, Tilini, once again. And that is the end of this session. So thank you very much for your participation and contribution. And now it's over to you, Kavinda.
Thank you, madam. So thank you, Dr. LNC De Silva and the authors who presented. So with that, we have successfully concluded the first day of the conference. So hope to see you in tomorrow's session starting at 9 a.m. So have a good day and stay safe.